Hello viewers on YouTube. In this video tutorial, we are going to focus on how to find the partial derivative of multivariate functions that consist of the quotient of two other multivariate functions. So let's talk about what I'm saying next sense. I mean this kind of function. Consider z of x, y to be equal to a function of x, which is also a multivariate function, divided by another function of g, which is also a multivariate function. Then z entirely consists of two other different multivariate functions that are quotients of each other. Now, to find the partial derivative of z with either with respect to x or y, there's a rule that would guide you, and this rule is called the quotient rule of partial derivative. So what does this say in exercise? So it's similar to that of our differentiation, but let's state that it says that the partial derivative of z with respect to x is simply equal to the multivariate function g of x, y multiplied by the partial derivative of f with respect to x, and minus the multivariate function f of x, y multiplied by the partial derivative of g with respect to x. Then you divide this entire expression with the square of the multivariate function g of x, y, and then you have the partial derivative of z with respect to y. With respect to x. Same thing applies to z sub y. So, in your mind, what do you think z sub y would be in terms of formula, using this as a reference? Have you done that? Perfect. Do you got it right? Let's see. So that would simply be equal to g of x, y. But instead of multiplying with f sub x, since we are not considering a derivative with respect to y, we need to multiply with f sub y. Then we subtract the product of the multivariate function f of x, y with the partial derivative of g with respect to y, and then divide the entire expression with the square of the multivariate function g of x, y all squared. Perfect. So this is the formula that will help you to successfully differentiate partially a multivariate function that consists of the quotient of two other multivariate functions. So to put this into good use, let's consider some practice problems. Example number 1. Consider the multivariate function z of x, y that is equal to 6x plus 7y, all divided by 5x plus 3y. So if you know what to do already, feel free to pause the video and figure this out. Then after that, you can unpause it and see if you have actually done the right thing. So the first approach should be identifying our f of x, y and our g of x, y. So clearly, since f of x is usually the top function, so that would in this case be 6x plus 7y. So f of x, y, I'm about to write plus. F of x, y is indeed equal to 6x plus 7y. Then similarly, g of x, y would be 5x plus 3y. Now, having identified the other two multivariate functions f and g, let's find the partial derivative of each of these functions with respect to x and y respectively. So with what we have, what do you think would be the partial derivative of f with respect to x? Well, clearly we just need to pay attention to the terms with x, as the terms with y will be considered as a constant. And whenever we differentiate the constant, we know that that is always 0. This can be get rid of. We can actually ignore it and pay attention to 6x. When we differentiate 6x with respect to x, we have 6 And this gives us f sub x. Now, what about f sub y? Clearly, we just need to consider this to be a constant as well. Pay attention to 7y. Differentiating 7y with respect to y, we have 7. And thus, we have our f sub x and f sub y. Now, on to g of x, or g sub x. The partial derivative of g with respect to x will simply equal to 5. Without wasting much of our time, we know that should be 5. Because no x can be here, it means we need to consider the entire 3y to be 0. Because we have to consider the derivative of the entire 3y to be 0. Because 3y is a constant. Likewise, g sub y should be 5. Sorry, it should be 3. Because this has become 0. Now that we have f sub x, f sub y, g sub x, and g sub y, we can proceed on finding the partial derivative of z with respect to any of the independent variable. Let's begin with x. Earlier, we stated the formula, but we need to write it back so you can get the process to full potential. Okay. Likewise, if you are doing a theory exams or test, it's recommended there's always marks assigned to the formulas when you have them written down. So z sub x, we said, is simply the product of g of x comma y times f sub x and minus f of x comma y times g sub x, and you divide it by the square of g of x comma y. That's it. So would this place be enough? I don't think so. Let me just put it under. G of x comma y is simply 5x plus 3y. So we got it right here. We have to put that within the parentheses because it's binomial, and we'll have something to be multiplying it. So to have a clear picture, let's put it in parentheses. F sub x is simply 6, so we multiply by 6. The minus f of x comma y is 6x plus 7. Since it's a binomial, likewise, we can put it within the parentheses to separate it. It's a plus. And then we are multiplying with g sub x. G sub x is simply 5. So right now we can divide all through by the square of g of x comma y. And that's simply 5x plus 3y all squared. And this is our result. If you want, you can expand, simplify, get your answer in the list form. And if you don't want, you can leave your answer this way. But let's try to be simple. Okay? So let's simplify. So simplifying forward by expansion, we have z sub x to be equal to 6 times 5x is simply 30x. Then 6 times 3y is plus 18y. Now, I'll be considering this minus being attached to 5 because they are all together. So minus 5 times 6x is minus 30x. And minus 5 times 7y is minus 35y. Then we see have a division of 5x plus 3y all squared. Incredible. So, one last step. Finally, z sub x would end up being, these can actually get into themselves, and the sum of 18y and minus 35y would give us 17y. Well, the minus will still be there. Then we have it to be divided by 5x plus 3y all squared. Thus, we have our results to the partial derivative of z with respect to x. Now, what about z sub y? Let's now pay attention to z sub y. Please, I hope you are following each of the steps expected. Now, for z sub y, just as the way we wrote the formula for z sub x, let's repeat the formula for z sub y. So, you can recall. If you recall, that z sub y is simply the product of g of x comma y and f sub y, or minus f of x comma y times g sub y, and you divide that with g of x comma y all squared. Perfect. Now we can proceed on substituting. G of x comma y, by now you should know what that is without even highlighting it. Is that? So that's simply 5x plus 3y. Then our f sub y is 7. We have actually shown it out. So we have times 7 minus f of x comma y is 6x plus 7y. Then we go to the right here. Times g sub y is 3. And then we can divide all through by the square of g of x comma y. So our g of x comma y is 5x plus 3y. And then we need to square that. So this could be our final answer, but we want to be simple, as simplicity is one of the best. Yeah. So z sub y is now be equal. So 7 times 5x gives us 35x. 7 times 3y is plus 21y. Alright. Now, just as the way we attach the minus with the 5 earlier, let's do the same thing by attaching it to 3 here, because they are actually together. They are bounded. So now 3 times 6 will gives us minus 18x. Okay, and then minus 3 times 7y is minus 21y. We still have our division of g of x comma y all squared, which is 5x plus 3y in this case. So this can go, and then we can have our last step for z sub y to be these can also cancel themselves. Alright, so it means the game is to draw. Okay, while solving for z sub x, the x terms cancels for the numerator. Now that we're solving for z sub y, the y terms cancels, so no issue. Now 3x minus 18x, so 35x minus 18x is simply 17x. Then we have it divided by 5x plus 3y all squared. So this is z sub y. So guys, this is how you can easily find the partial derivative of a multivariate function that consists of the quotient of two other multivariate functions. So for better understanding, let's consider a few more examples. On to example number 2. So feel free to pause the video and try this yourself. So consider the function z of x comma y that is equal to 3xy squared plus 11y all squared divided by 2x plus 6yx cubed. Perfect. I know that problem is a power, not a coefficient. So the very first step should be identifying our f of x comma y and g of x comma y. Doing it that way will actually make things very easy for you, as you just need to be thinking one step at a time. That's basically how lives work. So now f of x comma y is simply 3x plus 11y xy squared. Okay, I can see that. I should entirely write everything back. I'm trying to manage that space. 3xy squared plus 11y all squared. Okay, perfect. And our g of x comma y is 2x plus 6yx cubed. So now that we have these two, The next step is to find the partial derivative of f with respect to x and y. Likewise, the partial derivative of g with respect to x and y. So let's start with the partial derivative of f with respect to x. But f is a multivariate function, but it's still a square, it's still the power of another multivariate function. So to find the partial derivative of f with respect to x and y, we just have to be sensitive, as we have to probably go an extra mile process. Okay, not probably, we have to be certain. So what am I saying next sense? In partial derivatives, there are some rules, and I've actually done a video on that. We call it the chain rules of partial derivatives. That's one of the rules, and that's the one we're going to be using right here. Okay, what does this rule say? It says that when you have a multivariate function z of x comma y, for instance, that is equal to the power of another multivariate function, let's say k of x comma y in this case, all this power n, then the partial derivative of z with respect to x would simply be equal to the power multiplied by the partial derivative of the inside multivariate function k with respect to x, then again multiplied by the function back itself, k of x comma y, all raised to the power of the power initially reduced by 1. So this formula is not boring, it's not confusing. Just take a time, look at it. What does it say? This will come to the front first. It's similar, very similar to that of our differentiation chain rule. Okay, this comes, then you differentiate the inside, or make sure it is with respect to x. That's how we got the case of x. Then you multiply it by the function back itself, but raised to the power of n minus 1. You know, you have to reduce the index by 1. That's what this formula says. Now, if you look at this, and f of x comma y, then you will realize that they are similar, because f of x comma y has a multivariate function inside, and outside it has a power. So thus, to find f of x comma y with respect to the partial derivative of f of x comma y with respect to x or y, we need to use this logic. Am I complicating? We can't use the normal logic, because that one gives us our actual answer. So now, f of x. So f of x will simply be equal to the power, which is 2, and is 2. So we have 2 multiplied by. Now let me just see like this. Keep in mind, you can see k of x comma y to be 3xy squared plus 11y. Okay, this is 11, not 1. Okay, 2 times case of x. Remember, case of x, you are multiplying with case of x. Case of x, so differentiate this partially with respect to x. 11y can be considered as a constant, thus it has to become a 0 by the time we differentiate it partially with respect to x. Now, differentiating 3xy squared partially with respect to x will then just give us 3y squared, because this is just x. By the time we differentiate it, we will have 1, and 1 times 3y squared is simply 3y squared. So we have 2 times 3y squared multiplied by the function back. Okay, that's k of x comma y. So put in a bracket 3xy squared plus 11y. But now the index will be reduced by 1. 2 minus 1. So f of x would be 2 times 3, that's 6y squared, multiplied by 3xy squared plus 11y, all to the power of 1, which is actually the same as not writing end. So these are our f of x. Please, I have to get the concept. Please just take the time and look at it. Basically, since k of x comma y has become 3xy squared plus 11, so you can see f of x comma y as k of x comma y all squared. Okay, now if you want to differentiate partially f with respect to x, you need to, f of x will be, the power will come first, so you multiply 2 by, you differentiate this thing with respect to x partially, so k of x, then you now multiply it with k of x back. Just everything here but you could use it by 1. Okay, just the index. So that will be multiplied by k of x comma y, or x power 1, which is 2 minus 1. So that's the formula. That's the rule. Is that okay? So that's what we have actually done so far. I hope you get the logic now. Perfect. So now that we have f sub x, let's do f sub y. So what will now be f sub y? Well, just like before, we just need to change where we need to differentiate partially with respect to x to y. So the formula would be in this sense. That would be n times k sub y times k of x comma y, all is power n minus 1. So that's the formula for f sub y. Thus, n is 2, as you can see. So we have 2 times, now k of x comma y is 3xy squared plus 11y. If we differentiate it with respect, partially with respect to y, what would that be? What do you think? So what exactly would be k sub y? That will be equal to what? There's y term here, there's y term here. So we can't consider any term to be 0. Okay? Now, differentiating partially 3xy squared with respect to y. What do you think that would be? Well, the 2 will come, we reduce by 1. That will be 6xy. 6xy. Am I communicating? So the 2 will come, multiply with 3, that's 6. The x is still there because it's a constant. Then y is here. Nice one. Oops. Then plus the partial derivative of 11y with respect to y is simply 11. Okay, and then we have k sub y. So that's what we are using. So we have multiplied by 6xy plus 11. Okay, then finally multiply by k of x comma y, which is simply 3xy squared plus 11y. Now we have to reduce by 1. 2 minus 1 is 1. It's the same way as not writing anything. So this is our f sub x, and this is our f sub y. So that's it, guys. Now on to g of x comma y. We need g sub x and g sub y respectively as well. So I can get it off entirely. I don't need them anymore. As you can see, g is like a pure multivariate function. It doesn't consider. I want to make this straight. I want to make it straight. Just trying to split the boy. Right. G doesn't in any way consist of probably a square of another multivariate function. It doesn't. It's a straightforward multivariate function. So those we need to partially differentiate it by using the normal techniques. So g sub x will simply be paying attention to the terms with x, but there's x terms in both places. So yeah, in all cases. So therefore, differentiating 2x partially with respect to x is 2, plus differentiating 6yx cubed partially with respect to x would be 6 times 3, which is 18 yx squared. What have I done? The 3 comes, and not all the way to that point, but to the 6. 3 times 6 is 18. Then you reduce it by 1, which is 2. Y is still there is a constant. Am I communicating? Perfect. That's g sub x. G sub y, that would be what? This will be a constant, and that will be 6x cubed. Because the time we differentiate that y that is there, it becomes 1, and 1 times 6x cubed is 6x cubed. So that's our g sub y. Now we can proceed on finding g sub x and c sub y. But I think this piece will be the best to use. Thus, we have to copy this all the way to this point. So f sub x is 6y squared 3xy squared plus 11y. Okay, and f sub y is 2 times 6xy plus 11, then times 3xy squared, and what is it again? Plus 11y. Nice one. So this can go, and then we can have g sub x. So did I need to still repeat the formula? Yes, I need. Okay, for those who might have already forgotten, but please make sure you always have that back of your mind, yeah, in case of incasity. So g sub x is simply g of x comma y times f sub x minus f of x comma y times g sub x divided by g of x comma y all squared. So g of x comma y is this one. So it's a binomial. We can put it in the bracket. So we have 2x plus 6yx cubed. Then we are multiplying with f sub x, which is this. Thus we have times 6y squared multiplied by 3xy squared plus 11y. Nice one. Then we have minus this minus right here. F of x comma y, which is this. Okay, that's simply 3xy squared plus 11y all squared. Then multiplied by g sub x. G sub x is this. So we can put in the bracket 2 plus 18yx squared. Then don't forget we are dividing this entire expression. Should I put another bracket here? Yeah, to know that they are all the same, all together, divided by g of x comma y, which is 2x plus 6yx cubed all squared. So that's our g sub x. Am I communicating? I hope you're not lost. Okay, g of x comma y is this one, 2x plus 6yx cubed. That's how we got this. Okay, then for f of x, f sub x, we got that to be this. Okay, and that's how we multiply this one with that. Okay, then for our f of x comma y, that's simply this one, and then our g sub x is simply this one. Now on to g sub y. So for g sub y, or z sub y, sorry, that's simply g of x comma y times f sub y minus f of x comma y times g sub y divided by g of x comma y all squared. So g of x comma y is simply 2x plus the big bracket, new bracket, small one, to the previous one. So 2x plus 6yx cubed, and multiplied by f sub y is this long expression, 2 times 6xy plus 11 times 3xy squared. Oops, I'm supposed to manage that place, but I just have it plus 11y. Okay, perfect. Then we have minus f of x comma y, that's 3xy squared plus 11y all squared, multiplied by g sub y, that's 6x cubed. And we multiply everything, also we divide everything by the square of g of x comma y, that's 2x plus 6yx cubed all squared. So that's our z sub y. So that gives us the solution to this problem. Guys, this is how you can easily find the partial derivative of a multivariate function, regardless of how it looks. So far, it is a quotient of two other multivariate functions. So I want to believe in one way or the other you gain something from this video, and at the same time I want to believe you find it helpful. Thanks for watching. If you are new to subscribe, feel free to subscribe to the channel, and also if you're enjoying the video, you can leave a like so YouTube can recommend it to many audience out there. Thank you for watching once again. See you in the next video. Bye for now.